Yeah, thanks for inviting me to your group. Um, Quite a ways away from here, down in Oregon, I suppose. Beautiful country down there. We got our own little piece of paradise here, Vancouver Island. My job here at the museum, I'm the curator of natural history. I've worked here for 33 years. I get to go fossil collecting just about every day. I take classes of kids down there. I take adults. I take everybody down to the river. I supply hammers, chisels, and goggles, and we look for fossils. The people take the fossils home, and they're really excited about it. And they can keep the fossils they find unless I think they found something significant to science, in which case they would be donating it to the museum. All the fossils that we have here in British Columbia now, there's rules and regulations. There didn't used to be. All the fossils belong to the province. So when you find one, you become the steward, the collector, the protector, the custodian of the fossil, but not the owner. So we've had the sale stopped. No collecting in parks, regional, provincial, or national parks. Um, I just want to show you what Vancouver Island looks like today. It's a beautiful place. Uh, but in the past, we'll just go back a little ways back, about 85 million years ago. It looked like that. So Vancouver Island was under the ocean and Lake Cretaceous. Um, it has quite a journey. Our island started probably below the equator, maybe 15 degrees below the equator. Vancouver Island, Haida parts of Alaska. It's called Rangelia. Moved north on the Pacific Plate, and then we ran into North America around 100 million years ago. And when that happened, our island got shoved up into the sea for the first time, and it got to see the light of day. And we think it became more of a tropical swamp. And but the ocean levels are going up and down here on the coast of Vancouver Island, and the water went up and down a dozen times. And as it went up, it covered this forested swamp with sand, and then it retreated, and then it grew another forested swamp. But those forested swamps became the coal beds of Vancouver Island. Most important fossil ever discovered here because Vancouver Island was the first place coal was discovered on the west coast of North or South America. So back in the late 1800s, it became the energy supply for the Pacific Ocean. So we have a large coal supply. Just put all of our little communities up and down the island, their first economic development was coal. We usually don't find those dinosaur types in there. That hadrosaur, you see that? My brother, he did find a duckbill. It was misidentified for many, many years as the tail of another plesiosaur, but we just found out it's the tail of a duckbill. It's the first articulated dinosaur from the west coast of Canada, which is kind of cool. But after these forested swamps, the ocean levels went up and they covered Vancouver Island with water. It's about the same time it flooded Texas, Kansas, Saskatchewan, Manitoba, it split North America in two. Sea monsters started swimming in there, but they were swimming here too. Where are the fossils? They're pretty well underneath the whole east coast of the island here. There's my proverbial bulldozer. If I could take that bulldozer and scrape all the trees and sand and gravel off um from Campbell River, just north of Courtenay, all the way south for 150 kilometers, you'd find that underneath there is an ancient seafloor from about 80 to 85 million years ago. But the place we get to look is in the river because we live in this beautiful rainforest and it covers all the fossils. So you can't really see them until you go to some of the beaches that are wave washed, but it's usually in our local rivers. And you can see the layering in there. It's shale is fairly hard packed. It's pretty friable right on the surface, but once you get in there 6 or 8 inches, it's like concrete. So it's not like the guys on TV with their paintbrush. Excavations are time consuming and a lot of work. So this is kind of the way the shales are laid up, um, west to the right side, east. to where the Hornby side is. And our island is not on it's not flat anymore. It's been uplifted on the west coast more than the east. So the east side of Vancouver Island is trying to subduct under the mainland of Powell River, and the back end of our island is coming up in the air. So then what you get is a layer cake that's standing on its edge. And that's why the coal layers are found sticking out because everything's on a bit of a dip. Typical things we find, of course, the bivalves, they're the most abundant. We get these large inoceramids up to 3, 4, 5 feet across. I've seen beautifully preserved ones. Um, There's a good sized one coming out of a ditch at the motocross track in Nanaimo. Lots of these crabs. I know somebody that has 500 of them, these Longosorbus caniculosus from Shelter Point, just north of Courtenay. They're molts because they're complete. You tell they're molts because nobody ate it. They just walk out of their shells and leave them behind. So there's a lot of these. But we have, lots of different types of crabs here. Many, many different ones are being described. We have a guy down in California, Loma Linda, who is the best crab guy in the world, and he's described probably at least a dozen or 2 dozen new species of crabs from Comox Valley here. Lots of ammonites. These are typically ammonites from Alberta. You have your straight-shelled baculites and you have your planospirals. That big one there being depicting the one they make the jewelry out of, amylite. That's Placenticerus meekai. We don't get that type of preservation here. We don't get that. Rarely do we get the nacre that'll give that iridescent shine. Um, Most of ours are drab brown. Over on Hornby Island, some of the fossils there, the large baculites, you could shine them up and they have a nice, but you have to use like 5,000 grit and a lot of work. But the fossils around here, this is typical. This is what we think the ammonites look like. We find their apticus, their beaks. The scientists in Japan said if there was a spot with apticus, if there was a box in the world, said the Courtenay Museum would have like a quarter of that box with the beaks of octopus, squids, and ammonites. This is large Canodosaurus, reconstructed. The guys found like 10 of those in a line one day on the beach, and they're all, bigger than a dinner plate for sure. But we do have these weird, wonderful heteromorphs. Um, so evolution is a series of genetic mutations followed by natural selection. So, but the mom, all the ammonites started out that way, that shape, planospiral, coiled on a single plane. Mom had 200 million years of evolution to look like that, even more. But then say you're a mom, you have 500 babies all at the same time, but there's a break in the genetic code. It's not the baby. The little baby's okay. He's got all his eyes and everything's fine, except the shell structure. The instruction is wrong. It starts to go planospiral, coil on top of itself, but then it goes sideways. But they all do it. And so now you have what we call heteromorphic ammonite, different than their mom. They don't even look like their mom at all. But these little wonkies, they usually don't last long because natural selection takes over because they're slow. Mom is pretty fast. These guys are slow. Predator's going to leave it alone for a while because they've never seen it before. It's going to leave it. But once they figure out that they're tasty too and they're full of protein and they're slow, they're going to eat them all. And so these ones become markers in time. All the ammonites in the world are markers. They all have a time period, each one at a certain time. So they take the first one to the last, pile them on top of themselves, assign a time. But then when you find something lesser like a plesiosaur, and you say, hey, how old is this plesiosaur? What kind of ammonites did you find? And so they tell time. I was fortunate. Well, there's my friend. Yeah, I'll let him go. That was my buddy, Finley. I used him to teach children with like online, and they really respond to him more than they respond to me. That's for sure. I was like the most boring thing I've ever seen on, but Finley was fun. This is a heteromorphic ammonite. Scientific paper just came out on it. Um, they named it after me. Yay. I found it on the beach up in Campbell River. It's called Elasmosaurus traski, and it's got this weird, weird shape. But I love it. Fossil in our collection here and in Japan. The North Island of Hokkaido has the same paleogeography as Vancouver Island. They were underwater at the same time we were. And because of that, we share same kind of fossils. And one of them that we share is these giant octopus. So in 2008, I was an author on one of the scientific papers, and we just from their beaks, their apticus, we were we made a mistake. We thought it was a vampiromorph, like the vampiroteuthis, the vampire squid today, but it's not. As a finned octopus, octopod. Um, these are cirrate octopods. They've got cirri under their arms. There's finned. But here's the thing. We didn't realize it, but the Japanese found some on the North Island of Hokkaido that were even bigger than the ones that we were finding. We figured this thing was pretty big. We never expected it. This is what they're saying. The size, um, between 7 and 19 meters. 19 meters. That's a 60-foot octopus. They say it's the biggest one in the world. It was just trending about 3 weeks ago on Google because they revisited that paper, the Japanese, and put out a new paper showing the ones, the beaks, the upticus that they were finding in Japan. But I mean, look at this thing, the size of those things. You could take down a plesiosaur. You probably take down a small ship. There's lots of controversy, I would say, as to the size of that animal. We find fishes, of course, you guys, um, fins, vertebra, teeth, those types of things. I was with the guy who found the first ratfish in Western North America for the Cretaceous. It was a new species, Edaphodon hesperus, a ratfish. I was looking at your website and somebody found a chimera from the Oligocene. Well, I knew exactly what it was because somebody found one here on Vancouver Island from the same time period. It looks exactly like the one you guys got. And it's a beautiful thing. Ratfishes are cartilaginous. The only thing that becomes fossil is their tooth plates. But the one that we found would have been probably about a maybe 6 footer. That's a big ratfish. Um, we found a complete tooth place. It's the most complete ratfish ever found, I think, from especially that time period. The only thing we didn't find that would have been a fossil would have been its venom spike. They say it would have had like a 14-inch venom spike. So on their dorsal fin, don't play with the ratfishes because they can actually sting like several bees at the same time. And this young girl, one of my tours, found a shark. So I was one of the first ones here to ever find a shark vertebra. Usually you don't find them because they're cartilaginous, but in this place and this time, the chemistry was just right for the backbones of these sharks to become fossil. Interesting thing about sharks is they grow a new ring on their backbone every year, so you can age that shark. So that shark in her hand was 85 million and 27 to be exact. Well, 27 for sure. So the first vertebrate ever found in this area on Vancouver Island was back in like 1985. And somebody found like a femur and a scapula, a couple of pieces of jaw element from a turtle, a very large marine turtle. And they recognized it as a unknown species and genus, so Desmedicales loa. It got a little bit of press, but not a lot. It's just that, turtles are still around and it was misidentified. It took a while to get to the press. and to science. But then right after that, 1988, my brother, that guy, that's Mike Trask. That's my twin brother, Mike. He was a surveyor and a draftsman for the Department of Highways. And he was down at the river with his daughter looking for fossils. They'd been there before, clams, snails, crabs, ammonites, the usual suspects. But this day they found a bone. And this is what brought me here to this museum is this discovery. I came here to promote my brother's discovery. That bone turned into another. You can see three in a row there. Over time, we had volunteers come from the community and they took the bank down. So my brother had found the neck, the head, and the rest of the body was underneath the bank of the river. It took about 4 months with about 40 volunteers. They'd take the forest off the top first. And then my brother said with hammers and chisels, they took off about 12 full gravel truck loads of rock off the top to get to the body of the animal. And most of the animal was in concretion. You guys know about concretion, how hard they are. And that's what it looked like when I got here. It was just a pile of rocks. People come from all over the place. They wanted to see it. It was wrapped in newspaper. You couldn't even tell it was bones. Kids are crying because it didn't look like anything. So my brother was a surveyor and a draftsman for the Department of Highways, so he kept really good notes. Head at the right end there, it's the right side, and tail at the left. You can see the necks in a couple of circles there, and I think maybe something tried to twist the head off. Sharks will do that. Then the neck's articulated, and then there's a gap where the necks are bones are missing, but they're pulled back on themselves. Something physically grabbed that neck and broke it, pulled it back. But then the main body's jumbled up, but that's what you'd expect because that's the soft parts of the animal. Yeah. My brother phoned me one day. He said, I had my 15 minutes of fame. We dug it up. That was in 1991. And he thought it was over. And he suggested I quit my job and get involved. So I did. And because I didn't have a job, I got to go fossil collecting every day. But then I got to learn all the names of all the fossils because there was nobody out there 35 years ago, nobody looking for stuff. Very few. But my brother introduced me to scientists, and those guys taught me too. And so I had a whole bunch of mentors. My twin brother Mike, he was Mr. Science when we were growing up. I was more social. So this job fits me because I can relate to people. Sometimes academics have a hard time. So this is what they found. If you look down below there in the display case, there's the bones going around the corner. There's a whole neck going around the corner. It's a long neck plesiosaur. Now, first elasmosaur, they're the long neck plesiosaurs. So there's three types of plesiosaurs. There's long neck ones called elasmosaur, which means thin plated reptile. Then there's short necked ones called polytechilids. And then there's no necked ones called pliosaur. But these ones are the long necked turtle shaped bodies, Elasmosaur. The first one ever found, they found it in Kansas back in the late 1800s, and they called it Elasmosaurus platyurus. So that's the genus and species. This one was never an Elasmosaurus. We knew that. It's the wrong place, wrong time. But it was unknown as to the genus or species. So the first time they ever put one together, the guy put it together wrong, put the head on the tail. We found the head at the right end, so we're pretty sure it goes that way. But the reason they're called elasmosaur, fin-plated reptile, is because of their body style. Their neck is not like a snake. It can't actually reach back and bite his toes. So he's actually defenseless. As he's swimming along in the water as a marine reptile, they can't stop creature from biting their stomach. So as their neck got longer, their body armored up. So underneath, they have armored. It's armored. It's all boned up with large scapula, large shoulder blades. It has a large breastplate called the coracoid. interlocking belly ribs that run down the middle of its stomach. And there's three ribs that kind of twist tied together in the middle. And um, and then there's a large pelvic plate. And then there's ribs on their back, and that keeps the sharks out. So it's a awesome body plan. And this is a reconstruction. So when I got to the museum, it looked like that. The thing looked like that. We're lucky we met a guy from Alberta who builds dinosaurs for museums, and his clients were asking for an Elasmosaur model. But to make one of those models, you have to have a specimen. So he hired a guy from China to clean it. It took him 3 years, or sorry, 2 years just to pair it, because most of the bones were in concretion. But that animal laid on the seafloor for a long time. So the lead author on the scientific paper, Robin O'Keefe, he described it as melted soft ice cream. And what had happened was the bones got like microbed, eroded, and seawater erosion. And then just about every bone in that thing had to be touched with a tool. And so because of that, they were reluctant to name it or give it a name, a scientific name. So we just called it Elasmosaur, the Comox Valley Elasmosaur, or the Puntledge River Elasmosaur, where it was found. But I knew that what we'd have to find is another one. We'd need to find another one to get this one described. And so it was imperative that somebody found one. And this is what they look like. They're an awesome animal. So what there was when they dug this thing up, they used volunteers from the community. But those volunteers, they wanted to learn more. So we formed a society, the Vancouver Island Paleontological Society. And from there, another one formed in Qualicum Beach, the Vancouver Island Paleontological Museum Society, one in Victoria, the Victoria Paleontological Society, one in Vancouver, one in Tumbler Ridge. There's a couple others that have since folded, but those ones, those main ones, they're amateurs. We don't like to use that word anymore, so citizen scientists. And from that was born the British Columbia Paleontological Alliance. And that board is made up of scientists, professionals, and citizen scientists, a bunch of PhDs, and some of us that don't have that. But amongst ourselves, we've lobbied the government for rules and regulations in the province. And one of the things that we asked for was a provincial fossil. There was a committee set up. The government said, okay. There was like everybody said, "Oh, send in your favorite fossil from BC." So there's like 200. Everybody's got their favorite fossil, and their committee whittled it down to seven. Right. So the Elasmosaurus was one of things candidates. Shonosaurus, a giant ichthyosaur from Pink Mountain, a Canadasaurus, which is an ammonite. Yabina, single cell organism, but he's giant on steroids. Oleonides, a trilobite, Marella, the lace crab, and Eoselma turquoidensis, which was a salmon from the Eocene. But our Elasmosaur won. He got 48% of the vote. The next one down got 15. So in 2023, the best thing ever happened to us was the Elasmosaur was adopted as a symbol to represent the science of paleontology in the province of BC. So that sea monster now represents fossils. So we have a flower and a tree and a rock and a mammal and a fish and a bird. We got all those things, but now we have a fossil. So I don't know if you have one in your state, but I know my friend Peter Ward. Hey Pat, you guys, how did you do that? And then big emails on how to do it. You got to get you got to get the government involved, blah blah blah. And then he wanted to get one for the province. Sorry, for Washington. And then after all this, I look it up and I go, they already have one. It's the mammoth. That is the state fossil of Washington. 30 years later in the Trent River, I'm down there. I do tours. A lady found a finger bone. A year later, a dad finds like a wrist bone, like a metatarsal. And I go, a finger bone laying at the bottom of this cliff, and now a metatarsal. There's something in that cliff and it's waving at us, and his fingers are falling out. It took a couple more years to figure out where it was and kept finding pieces and little clues. That was a pretty good clue because there's a bunch of ribs in that rock, but also in that rock, there's a bunch of rocks, like real rocks. Those are gastroliths, stomach stones. And I knew it was from his stomach because elasmosaurs don't chew their food very well. Their teeth overlap like a trap, so they swallow rocks to aid in digestion. It took about a couple years after that first couple of bones to figure out where it was in this cliff, and it was way up there. So I spent 2 months um, there digging out a juvenile. It turned out to be a baby Elasmosaur, but he's not like baby. He's about maybe would have been 12 feet long. His body was like 5 feet. So their neck and head, yeah, maybe 10 to 12 feet long. This is one of the plaster jackets that I had to take down. That jacket weighed 250 pounds. And I had to manipulate that by myself up there because there was no room for anybody else. It was too dangerous, too sketchy. If you find a vertebrate in the province of BC, you're not supposed to dig it up without a permit. You're supposed to go through Heritage Branch. And they're going to say, where's it going at the end and who's helping you? So I had the whole crew of the Vancouver Island Paleontological Society, these guys helping me get this thing down. It was very important to me to have this described. And there's the lab downstairs, 3 4 by 8 tables. It took us 2.5 months to clean it. I was on that ladder for 2 months, and then 2.5 months in the lab trying to put it back together the way we had it. Of course, that's you know how those air scribes go, and sandblaster. Of course, a lot of interest. This is the former premier of British Columbia, John Horgan, recently passed away. But he wanted to see this little juvenile. And it was just laying it out on the table there, just the pieces that I was bringing down from the cliff and sort of putting them on the table, giving me sort of the orientation of where it was laying. So there's the two plaster jackets, and there they are cleaned. So it takes a while to do that. There's a lot of glue in there. This is what it would have looked like, but we didn't find it all. The head, the neck, the front left flipper fell off the cliff before we got there. But we found the back part of it. So in May 23rd, 2025, last May, a scientific paper came out describing these two animals. And they decided to name it after my family because it was my brother and his daughter that kind of started this whole thing. And, my input with a juvenile took it over the top. So we met a guy from West Virginia, Robin O'Keefe. He was the scientist on the job, and a couple of researchers from the University of Washington, another researcher from Chile, and me, and the scientific paper saying that it's new genus and new species. So the artist that did this, he uh, he put that camouflage on their neck, like the sea crate, the sea snake. And just so that model effect, it might camouflage it in the water. We're not exactly sure. Their neck is not like a snake; it's out fairly rigid in front of them. Some of the findings from the paper was that its teeth are quite robust, and they could have eaten ammonites. They could have crunched their shells. They could have picked up clams. but they're probably like fish eaters. I think they come from above. Um, they say their neck doesn't isn't flexible left, right, or up, but it flexes down. So I think because they're air breathers, they're going to maintain themselves near the surface and they're going to be swimming along like a turtle with their head down. And they're going to be looking down. And then when they see something, they're going to swim down on it. And that's one of the things that they found was in their flippers, in their femurs and their humerus, is that the top of the humerus was and the femur was flat and the bottom was curved. So reverse airplane wing. So they suggest it has a down force that it can come down on its prey. Fishes, ammonites, octopus, squids, probably diving birds. Might have been its prey. Our Elasmosaurus, now Traskosaurus sandrae, is celebrated every year. Birthday party, the community comes. Every year we have like 400 people come to his birthday party. And I found that kids love all of this. It's really important that we teach them right. You know, I get all kinds of kids in there, kids that love dinosaurs. And every time there's a new Jurassic Park movie, there's a bump, right? We get a new crop of kids. But you know, the plesiosaurs are cool, but we keep finding other things too. There's giant like mosasaurs, right? This was in 1991. My brother was leading a field trip, and this guy reaches into the bank and pulls the tailbone out, but it went straight in there, and it was almost complete. It took us 2 years to get it out, mind you, and a helicopter ride. And a small mosasaur called Puntledge ensis, Corisodon. It's a new genus and species. So Coris razor odon tooth from the Puntledge River in Courtenay here. And that's the reconstructed skeleton. But from where we started on its tail, which was maybe a third of the way from the end of his tail, all the way to his nose was touching. So the little fossil that I found, the little Traskosaura, the small one, it was complete. Nobody ate it. The one my brother found, 80% complete. And this one would have been 100%. We're finding complete animals. And this is the small mosasaur. And they think it might even be Clydastes, already known, but right at the moment, they said it's new Corisodon. This rock was found when they were making the highway to Campbell River. Teeth and jaws of a giant mosasaur would have been about that big. That model's based on one they found in Manitoba. But this rock, teeth and jaws, it's like 1,500-pound rock. You see all the scratch lines in here from the tool lines. But if you look at that lower jaw of that big animal there, halfway back on its lower jaw, there's a break. Now these animals have like a hinged jaw, double hinged jaw. They have two extra rows of teeth in the roof of their mouth. In the middle of their forehead, they have a third eye for seeing shadow. They're very territorial, I suppose. They probably fight over the girl lizards. They would be definitely the predator of the sea, the biggest one at the time. Canada Post made a stamp for Elasmosaurus, celebrated in 2016. Interesting thing though, on the souvenir sheets, they were canceled with dinosaur tracks. It's pretty cool. And then all the souvenir sheets, 10,000 sheets across Canada said Courtenay, BC. And we never lobbied for this. It was cool. And there's the set, Dinos of Canada. And there isn't hardly any dinosaurs on there at all. You know, these guys weren't. Some of them weren't. I've endeared this Elasmosaur to our community. So that's our MLA, member of the parliament. That green guy in there, that's me, that big green thing. I've been a mascot in the parade for 30 years. And there's one coming up. I love Elasmosaurus. I gave out thousands of those buttons. Yeah, we don't find these guys around here, probably not. But we do find bloat and floats, right? So, I don't know how long I've been talking now, so I'm just gonna maybe stop right there because I could keep going. I'm going to stop share. Yeah.
So we let him keep going, or we had
So what would
enough?
you?
You keep going. Oh, the consensus is if you want to keep talking, you can. We may turn you off, but you can keep talking.
Yeah. Yeah. Okay. Um, I could take you out into the museum because I'm there right now,
It's
and you could see some of those creatures. I guess. I just walk out there. What do you think?
what?
Go.
Oh, we have a couple questions. What's that mural that was behind you that would
Oh,
look like a carved
okay. So
wooden?
no, these are ceramic tiles, and they were produced by a grade 11 and 12 students from Down Island. There was a show at the museum in Victoria. It was called Dragon Bones, Dinosaurs of China. And they were on the walls in there. And I said, hey, these are wonderful, except once this show's over, they're not going to fit with any of your exhibits. I said, I got some walls that need art. And so they said, okay. And they talked to the class and they said they could re-gift it to our museum. And then we bussed the class up here and fed them pizza. And they were pretty happy. But they're, you know, of course, the Western paleontologists understand that the dragon is just a misrepresented dinosaur. That's all. Because they were finding lots of them in the Gobi, in the past.
Well, thank you.
So I don't know if you can see this guy. There he is. He's pretty big. He's 11, 12 meters long. So we got him in a big display case here. Goes around the corner. And then we have a reconstruction of a juvenile right there. That's about exactly the size of the one I found. And I was amazed that we had that model already. And then I find one that's about that size. I'm like, oh, we should manifest them more. Um, here's a little guy, my little Trask. So we have lots of ammonites on display, these heteromorphs. So I had an artist, reconstruct some of these guys, these ammonites. Just weird ones. No, I don't know if you can see that. That one. Nostosaurus hornbean, after Hornby Island. So what's happening now is to encourage people to give their fossils up. We encourage the scientists to name it after the people. So there's like many, many species, and a few new genera being described. We usually don't find dinosaurs, but my brother, putting down a blanket for his wife to read a book, found the first articulated dinosaur for the west coast of Canada. So I understand there was one piece of bone, like maybe a large femur or something, found on one of the Gulf Islands. And then the only other thing that was found on dinosaur was the tailbone of one of those, ornithomimon on Denman. I've seen that bone. I'm not convinced, but the scientist says it is. But the one that my brother found would have been like, one of these things. Got a bunch of these replicas on display. I try to make this place that's the hulkiest T-Rex you'll ever see in a museum right there. Because that's a Home Depot Halloween lawn ornament. But you do what you can. We're a small place. We don't have a large budget, but we do have a lot of interest. We try to make the place as kid friendly as you can because my philosophy is one child brings two adults. We have a little stream that we have. Go through there with the fossils in it, the kids could see and explore over there. And it's a nice running little waterfall.
I got to admit, Pat, this is the most unusual presenter. Nobody else has ever just wandered around in a museum while he's giving the presentation. I think it's just really cool.
Thanks. Uh,